Hello, I'm Alex Westerberg, joined with David Nguyen, and this is New Tech Crash Course. Today, we're going to be talking to you about how nuclear power plants should be used to provide the main amount of energy worldwide, the misconceptions of nuclear power plants, and the pros and the cons of the usage of nuclear power plants. And we'll also have an interview that explains the main concepts of the power plant, all this and more after the theme. There are many parts that make a nuclear power plant work. There are three loops that pump water through the plant. There's the primary loop, the secondary loop, and the tertiary loop. Other parts include the control rods, the reactor vessel, the contaminant building, the turbine, the generator, the condenser, and the cooling tower.
In a nuclear power plant, there are two different processes, one called nuclear fission and one called nuclear fusion. Nuclear fission is when you take one element, typically uranium-235, and split it into two. A neutron is fired at uranium-235 and it splits and sends off two daughter nuclei. As for nuclear fusion, hydrogen-2 and hydrogen-3 are typically fused together to create helium, and those heliums are fused to create carbon, and so on. The reason why nuclear fission is typically used is because it's controllable and it sets off a chain reaction. When those two daughter nuclei hits another uranium-235, that uranium-235 will split and send off two more daughter nuclei, and which causes a chain reaction. As for nuclear fusion, you fuse them together, and then it creates a new element, and you fuse that together with a new element. But this is very dangerous because you cannot control it as nuclear fission. You can control nuclear fission by adding uranium-238, which absorbs the daughter nuclei released by these uranium-235s. When uranium-238 absorbs one daughter nuclei, it becomes uranium-239, which is stable. And another way you can control nuclear fission is with control rods. By setting them to different heights and percentages, you can control the releases of the two daughter nuclei. Here are some different types of radiation that is associated with nuclear energy. The reason why it's important to know about these different types of energy because each type of radiation does a certain amount of damage, and most of the time people think that nuclear power plants are very harmful and give off gamma radiation, but that's not true. Most of the time they give off beta radiation. And what each radiation is there's alpha, beta, and gamma. Alpha being the lowest in potency, and gamma being the highest. Alpha has a positive charge, beta has negative charge, and gamma is neutral. As for alpha, whenever alpha radiation is when an element such as plutonium gives off a helium, and that helium is the alpha particle. As for beta, beta is an electron. It's when an element such as potassium has one of its neutrons in its nucleus turn into a proton, which emits an electron. As for gamma radiation, all the nucleus closes in, it gets tighter and it gives off pure energy waves. This is why it's important because nuclear power plants give off typically beta radiation, which can be stopped by aluminum. The penetration ability of alpha radiation is paper or skin, as for beta is aluminum, and gamma is beyond concrete.
Radioactive decay is the process and time it takes for a radioactive substance to become neutral. But in our case, this would take millions and millions and upon millions of years for this to happen. This is where half-life comes into play. Half-life is the amount of time it takes for it to lose half its radioactivity, which would take millions of years. Half-life is used today in the world to discover how old an object or an artifact would be from a dig site, and in this case also how long it would take for an object to lose half of its radioactivity. Nuclear power can be used as a substitute for many other resources like coal and oil and geothermal energy because no CO2 is emitted into the air when in the process of nuclear power. But there is one downside, however, storage. Whatever waste is not used or recycled in the process of fission, it goes currently is being stored into the ground, and it sits there for millions of years before losing half of its radioactivity. There are many misconceptions about nuclear power plants. Some of these misconceptions are that nuclear power plants can blow up like atomic bombs, and nuclear power plants release harmful radiation into the air. But in fact, these power plants do not blow up, but instead go into meltdown, in which the core of the plant is literally melting down. Another misconception is that nuclear power plants release harmful radioactive particles into the air and the environments that we live in through the cooling towers. These cooling towers are used to cool down super hot boiled water used in the process of power plants instead of releasing chemicals, what most people think, into the environment. The smoke that you see is actually large amounts of steam that are being released to cool the water. These are only a few of the misconceptions that are associated with nuclear power.